Now it's time to hear from one of our fantastic sponsors from Bentley, and that is Claire Witkowski. Claire is the Chief Information Officer at Bentley. So Claire, if you don't mind coming on up, and while she's coming up, show her some love, everybody. Yay, welcome Claire.
All right. Hi, everyone. It's so exciting to see you. I spent this morning looking at some of the models, and I was so thoroughly impressed. You guys represent the future. Now, I'm just going to talk to you a little bit about the context in which the future's coming at you, and a lot of this you already know because you obviously kept it in mind when you were creating your models. The times are changing, and we're under a lot of pressure, right? We got urbanization. By 2050, 7 out of every 10 people will live in a city. And a lot of these cities are going to be mega cities with bajillions of people, right? So that's a huge, big deal. We also have population growth. Right now, there are 7.7 billion people in the world. By 2050, that's going to be 10 billion people. And all of those people are going to need food, they're going to need water, and that's all set against a backdrop of climate change. So we have a lot to think about and worry about. But luckily for us, there are really smart people like all of you who are working on lots of things, and we have lots of technologies coming. Now, there's all sorts of things I could talk about. If I put my CIO hat on, we could spend the next 20 minutes talking about machine learning and blockchain and all kinds of stuff like that would probably leave half of you bored. So we're not going to do that. What we're going to do instead is talk about the technologies that really have a direct impact on cities of the future. The first one is digital twins, also 3D printing, generative design, robotics, and new materials that are coming on the market. So I'd like to start with a video about digital twins.
A digital twin is a digital representation of a physical asset, process, or system, as well as the engineering information that allows us to understand it, model it, and get its performance. Typically, digital twins can be synchronized from multiple sources, including sensors and continuous surveying, to represent its near real-time status. This synchronized data can be used to gain valuable insights, to more fully understand the physical asset. Infrastructure digital twins, or iTwins, are emerging now because of a convergence of technologies that enable an immersive and holistic view of infrastructure. Now,
All right, I'm cutting them off on purpose in the interest of time. Sorry, Bhupinder. But I have to say, digital twins will help us manage our cities of the future much better. They'll help us to design assets, put them in the physical world, and then manage those assets through the digital technology that we have. The next technology that's coming to the fore is 3D printing. Now, 3D printing's been around for a while, right? In the 80s and 90s, we saw a lot of 3D printing in plastic. And a lot of hobbyists and libraries and schools got 3D printers so they could demonstrate the technology. In the 2000s, we started getting a lot more practical with 3D printing. And you can see here in the middle picture, we started using 3D printing, for one thing, for prosthetics, which is fantastic because it dramatically dropped the price of prosthetics for those who need them. And now 3D printing has become pretty standard. We can 3D print truck valves for Mercedes-Benz, for instance, out of metal. This picture here is important for you because this is the latest development, 3D printing in concrete. Now, these houses are both 3D printed out of concrete. This isn't regular concrete. It's not the kind of concrete that just sort of flows into a form and fills the space of that form. This is special concrete that's been made to be really stiff so that it can be squeezed from a nozzle, kind of like a toothpaste tube. So you can imagine this big frame with two nozzles hanging from it that extrudes or squeezes out the concrete, and each layer can sit on top of the layer before it. There are several proof-of-concept housing developments already underway, and the goal of these companies is to be able to 3D print a house in 24 hours. So that should drastically help with our housing shortage that will be coming because of urbanization and population growth. Another technology that's super interesting is generative design. Now, this one's a little bit complicated, so I'm going to try to make it simple for you. Generative design is basically being able to take, you use the computer, right, and you enter in some constraints, like I'm trying to create something that's a certain shape and it has to have a certain amount of wind resistance, or in this case, has to be able to support a certain amount of pressure. And what happens, if we could go back to the slide on the big screen for a moment, what happens is the computer spits out a whole bunch of options, right? So what you see over here is an Airbus A320 partition. Now that looks like nothing a human mind would have come up with. It actually looks like somebody took a bunch of spaghetti and dropped it on the ground and picked it back up, right? But in this case, the partition was designed for a certain shape and to be able to withstand a certain pressure. It was optimized for weight. And what the computer came up with was a partition that weighs 45% less than the traditional partition. So if you imagine an airplane where every piece is 45% less weight, that's 45% less fuel. That's 45% less carbon emissions. Generative design can be used to shape buildings for wind resistance, to mock up the shape of a building for shiftability in earthquake zones. So generative design, I think, will be used more and more in the way that we design things. Another thing that's come to the fore is robotics, right? And I've heard from a couple of the judges that many of you use nanobots in your designs, so that's pretty exciting. I'm not going to spend a lot of time on this. We all know about BattleBots, right? And we all know that robots are now being used in manufacturing. You can see a robot there in the car lineup. What I'd like to draw your attention to is the bottom picture. The bottom picture is a prototype farm called Iron Ox Farm. It's pretty incredible. It's a farm that's run entirely by robots. Entirely. There are no human beings. So the robots plant the seeds, the robots add the fertilizer, the robots make sure the water levels are right because this is a hydroponic farm. And what really interests me is through machine learning and artificial intelligence, the robots are smart enough to go up and down the roads, find the diseased or brown leaves, and gently pluck them off without ripping the whole plant out. Pretty incredible. In 1 acre of an Iron Ox farm, they can grow as much food as in 30 acres of traditional farming, and they use 90% less fertilizer. So that's a whole lot better for our environment, and important for us in our food scarcity problem. They can go vertical. So you can imagine huge skyscrapers where each floor is a 1 acre farm producing 30 acres worth of food. And finally, new materials. These are coming out all the time, and I'm sure some of you have ideas for new materials of your own. The picture on the left is probably one of the coolest things I've seen in all time, and you're probably thinking, you have a very sad life. But it is cool because it is bioconcrete. It's concrete that's mixed with bacteria, and when it gets wet, the bacteria converts into calcite. It produces calcite, which is a component of limestone. So it's essentially self-healing concrete. So just imagine, no more cracks in the sidewalks, parents, no more potholes, and the bridges that we build would last a lot longer because the concrete is healing itself as it gets wet, as it gets cracked. The second image that you see in the middle there is something that you can go visit yourself. That's DuPont Circle in Washington, D.C. Now, the rectangle in the middle of this image is a sidewalk, but it's a special sidewalk. It's a sidewalk that can produce electricity based on the kinetic energy or the foot pressure on it. So just imagine if every sidewalk in the world was like the sidewalk in DuPont Circle. Cities would be self-powered. We wouldn't have to worry about our energy crisis. And talking of our energy crisis, that little 2x2 piece of glass on the right, that is actually a solar panel. Now, it's not very practical the way it is right now, right, because it's tiny. But what the engineers are working on is trying to make it bigger and bigger and bigger so that every skyscraper, every office building could be covered in these solar panels as windows. Again, solving the problem of climate change and energy that we will need for the 10 billion people by 2050. So that's all pretty interesting. It's all pretty mind-blowing, right? You think, okay, well, things are changing all the time. There's so many problems to solve. Where do I even start? Well, I'm going to give you a little bit of advice to close with. So first of all, for the parents in the room, don't freak out when I tell you this, and for the kids in the room, don't freak out when I tell you this, but 4 out of 5 of you, by the time you graduate from high school or college, 4 out of 5 of you will be doing a job that has not even been invented yet. Doesn't even exist. So that's pretty amazing. And what that means is, honestly, I'm going to tell you, don't worry about having a plan. I know there's a lot of pressure to like figure out what your major is, right? Don't worry about it. You literally cannot plan for 80% of jobs being things that haven't been created yet. It's impossible. So there you go. The next time somebody pressures you for what are you going to major in, say, I don't have to have a plan, because Claire from Bentley told me that was not needed. There are a few things that you need to do, though. The first thing you need to do to make a difference in the world of tomorrow is make sure that you're following your passion. Do what you did with this competition. Do things that interest you, right? One of the sad things you're going to learn when you get into the working world is that you spend more time at work than anywhere else. It's so sad but true. So what that means is you better pick something that you're excited about and that you're interested in and that's fun for you. Because that means that whenever you're working, you're not really working, you're actually having fun. So follow your passion. Do what interests you, whether it's structural, electrical, mechanical, design engineering. It doesn't matter. Whatever you're interested in, finding a way to provide clean water for people. Figure out what your passion is and follow it, wherever it takes you. The second thing is work hard and be creative. It doesn't matter if you don't have a plan, but you do actually have to work, right? And having a strong work ethic, whether it's in your studies or later on in your career, will always take you really far in life. And be creative. I kind of squished two things in one there. It's important to be creative. Be the one who steps out and says, hey, why don't we maybe try making a sidewalk that creates electricity? Be creative about that kind of stuff. Be innovative. And finally, always add value. If you always add value every day, no matter what you're doing, you will make a difference to the future. So find ways to be helpful with your friends, with your family, with your classmates, with your school. And when you get into the working world, find ways to be helpful to the company, to your team that you're working on, to your clients, right? Because in the end, if you do all of that, you will make a difference. Thank you very much.